Okay, here we go. This is a graphing calculator for your response, okay? You have a 12,000 liter tank of water is filled to capacity. So right there, you want to understand, like, that is at time 0, it's filled to capacity. So R of 0 is 12,000. You don't want to miss that piece, okay? At time 0, water begins to drain out at a rate modeled by this piecewise defined function. So is R continuous at 5? Well, think about continuity. Your definition, R of 5 exists, and it does. You can plug 5 into here and get an answer. The limit exists. So let's look at that. Your limit as t approaches 5 from the left of R of t, does that equal the limit as t approaches 5 from the right of R of t? So from the left, it'd be 600 times 5 over 5 plus 3. And from the right, it'd be 1,000 e to the negative 0.2 times 5. When plugging those in, this is 375. This is 904.837. Those are not equal. So not continuous because limits are not equal. Okay, and you should state that out. I don't have room here, so I'm not, but you should. Okay, the limit from the left and from the right are not equal. Part B, find the average rate at which water is draining. So this is a rate right here. R of t is the rate. So the average value of that rate, from 0 to 8, you're going to do 1 over 8 minus 0, the integral from 0 to 8 of R of t dt. Now it is split up into 2, so you could do 1/8 times the integral from 0 to 5 of 600t over t plus 3 dt plus the integral from 5 to 8 of 1,000 e to the negative 0.2t. Okay, that just gets plugged into your calculator. All right, hopefully by now you know how to do that integral. And then don't forget to divide by 8. You get 258.052. Okay, so I need to erase that to be able to do the rest. The next one, you're finding R prime of the rate. And using units, explain the meaning of what that means, or explain the meaning of that value in the context of the problem. So for part C, I can actually do it up here. R prime of 3 is in this interval, so you're going to do basically the derivative of that. All right, plug it into your calculator. So R prime of 3, when you plug that in, that is 50. Now, this is, R of t is measured in liters per hour, so the derivative would be liters per hour squared. Okay, now, using correct units, explain the meaning. Again, I'm not writing this out because I don't have space, but you would say R prime of 3 is the rate at which water is draining out of the tank at time t equals 3 hours. The rate at which water is draining out of the tank at t equals 3 hours is increasing at 50 liters per hour squared. Okay, you want to make sure you say it's increasing at 50 liters per hour squared and use those units. Okay, part D. Okay, we are finding an equation involving an integral to find the time A when the amount of water in the tank is 9,000 liters. All right, write but do not solve. Make sure you don't solve it. Don't take the time to do that. So you need to find the time when the amount of water in the tank is 9,000 liters. So this is where this comes in. Remember, the tank starts at 12,000. Okay, so part D I'm going to write over here. The tank starts at 12,000. And then water begins to drain out at this rate. So minus the integral, you want to know a time A. So we're going to do the integral from 0 to A, okay, of R of t dt. And you want to know when that equals 9,000. So equals 9,000. Okay, so always remember, you have an initial value. That's the 12,000. It starts, it's filled to capacity. Then the water is draining, so 12,000 minus the integral from 0 to A of R of t equals 9,000, and 9,000 is what you want in the problem. Okay? So that is it for that one.